A client met his banker to discuss opening a restaurant in a busy airport. In us, he found a partner that understood the importance of reaching for the sky. First Horizon Bank. Let's find a way. Go to firsthorizon.com/Mac. An avid cyclist dreams of turning his passion into a business. He consults his banker to help find the best path. Now bike wheels are being built, and all it took was a little push to get rolling. First Horizon Bank. Let's find a way. Go to firsthorizon.com/Clint.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello once again. Thank you for joining us. This is the Space Nuts podcast. It's all about astronomy, episode 205. My name is Andrew Dunkley, your host, and joining me, as always, is Professor Fred Watson, Astronomer-at-Large. Hello, Fred.
Morning, Andrew. How are you doing?
I am quite well, thank you. How are you, sir?
I'm well too. I know we're not supposed to be time specific when we greet one another on these podcasts, but it's morning here, and it's going to stay that way for a little while. So let's call it morning.
We will, regardless of when people are listening.
Yeah, exactly. If they ever
some people will be listening to this months from now. Seems to be the way with podcasts. But anyway, that's terrific. Now, before we get into this week's topics, we have to congratulate NASA and SpaceX on their successful launch and the astronauts making it to the International Space Station. I saw the footage of the launch, and they went ahead. The weather didn't look too pretty, but they did it anyway.
Yeah, they did. I think it sort of brightened up at the last minute. I think they were chancing it a little bit, but the conditions were certainly different from when they cancelled it on Thursday, when they were worried about the spacecraft itself creating lightning. I don't know whether you saw I saw a tweet. It's on somebody's Twitter feed saying it was something to the effect that you cancel for possible lightning. And then there was some footage of a Soyuz liftoff, which was being struck by lightning all the way up. It was amazing stuff. I think it was real, but I'm not sure. So I think, maybe there's a slightly more gung-ho attitude across there in Kazakhstan.
Yeah, possibly so. Yes, indeed. Anyway, it's good that it happened, and it's created another piece of astronomical history.
Yeah,
and
fabulous.
The first American-based launch in, was it 9 years?
Yeah, 9 years. Yeah, that's right. Wow. And look at, when you look at the inside of that, I don't know whether you saw the footage of Bob and Doug floating around in the capsule. It's sheer luxury. It looks a lot different from any of the spacecraft that have been launched before, human spacecraft, and certainly
yes, indeed. Yeah. And we look forward to the first Australian-based launch in 2158, I think that's scheduled for. Now, today...
I don't think
today,
so.
Fred. Today, Fred, we're going to be looking at Planet-9. Well, maybe we won't be looking at it because now they're starting to think it doesn't exist, which I'm very disappointed about. We'll also be talking about a dwarf galaxy that's repeatedly impacted our Milky Way galaxy, which sounds like a bad thing, but it may have been the reason why our solar system exists. So, good thing, apparently. We'll also be talking about, a couple of questions. One involving who is in charge of the orbiting satellites with all the new satellites going up there. Is there a body in charge of controlling all of that? That's a good question. And a question we've had a couple of times, but we'll revisit it. Where is the centre of the universe? Daryl, just there. See? No, that way. Look over there. No. We'll try and explain it to you, Daryl, because I don't know. But I remember we got a question once asking the address, which may well relate to it. But anyway, we will investigate that. But first of all, Fred, Planet-9, yes or no?
Oh dear, you might be disappointed about this story, but I'm devastated because
you wanted to find it. That's why.
No, it's worse than that. There's a whole chapter of of Cosmic Chronicles, aka Exploding Stars and Invisible Planets, on Planet-9. Chapter 14 is called Stalking an Invisible Planet, and it even gave its name to the title of the US edition of the book, Exploding Stars and Invisible Planets. And maybe it's so invisible as not to be there. I did put a caveat in at the end of that chapter, something to the effect that, by the time you read this, we might have discovered Planet-9, so you can ignore everything that I've said already. Well, it may be that you can ignore it anyway, even though we haven't discovered it. So
you shouldn't feel too bad, Fred, because I watched that BBC documentary that dates back 10 or 15 years now called The Planets.
Yes.
And a lot of what's in that is now redundant because we've made new discoveries. Yeah. So, but that's just astronomy.
It is. And what I gave was a snapshot of our state of knowledge as of about July or August last year when the thing went to press. So, so we do our best. And it's still possible it might turn up, Andrew. This is not a death sentence for the idea of Planet-9. So let's just go back to what it's all about. This story goes back, I think, about 4 years now, to two separate groups of astronomers who are interested in the outer solar system. And the observations were made, and these were the groups of astronomers of some significance. These are the top guys in their field. But they noted that the icy asteroids out there in the depths of the solar systems are things we call Kuiper belt objects or trans-Neptunian objects. They're slightly different to those two things, but we can lump them all together. We know that they have extremely elliptical orbits, very elongated. And what they noticed was that the direction of the elongation of these orbits all seemed to cluster in one particular direction. And so these two separate groups of researchers, they did calculations on why this might be, why there's this sort of clustering of the alignment of the orbits. And what popped out of the calculations was a very large and very distant planet that would maybe be shepherding the orbits into the same alignment. In fact, these groups came to the conclusion that was the only thing that could keep these orbits narrowed down to that bit of the solar system, and hence the theory of Planet-9, which is assumed to be 5 to 10 times more massive than the Earth. Orbits that carry it way, way beyond the solar system. I mean, its nearest is 10 times away as far as Neptune is. This is the hypothetical planet, and more than 20 times farther away, 30 times perhaps farther away at its aphelion, the furthest point from the sun. Lots of predictions been published as to where it is, but nobody's found it. And what I've always said, and I said this in the book, that one of the problems is that the predictions place the planet pretty firmly in the Milky Way, where you're really struggling because there's so many stars. And what you're looking for is something very faint that's moving very slowly among a really rich star field. And that is intrinsically something that's very hard to find. So what is happening now? Well, I think there are two groups involved here, but I'm going to talk about one. And this comes actually from a conversation article written by one of the members of this group, Samantha Lawler. This group of scientists is called OSOS, which is a great name. OSOS is maybe it's OSOS in America. It's an acronym for Outer Solar System Origins Survey. Very nice name, Outer Solar System Origins Survey. And they actually kind of coming to a conclusion that maybe we've been led astray. And that's because these objects are so difficult to observe. They're generally speaking, the Kuiper belt objects are a long way off. They're small objects. some of them are only a few kilometers across. And when you think of the distances, many billions of light years, then you really have a problem. They're so faint. And what they're saying basically is that the ones that have been found maybe have been found preferentially. They've been at advantageous positions in their orbits and advantageous directions, and they're suggesting that our knowledge so far of the Kuiper Belt is highly biased. In other words, there's a lot more there than we have yet seen. That the biasing comes from these preferential positions where the objects are that have been found so far. And so the OSOS program has discovered some new or newly discovered what are called, they're actually called extreme Kuiper Belt objects because they've got this extreme eccentricity or elongation of the orbit. They've discovered what they describe as a handful of these, and there is another survey that's found over 300 of them. And both of these two new sets of discoveries can be shown to be, as Samantha puts it, they are statistically consistent with a uniform distribution. That means that the bias in a particular direction has gone away. And what she says is, so now two independent surveys, both of which carefully tracked and reported their observational biases in discovering independent sets of extreme KBOs, Kuiper Belt objects, have found no evidence for clustered orbits. So very, very interesting. They've done further work to test the Planet-9 theory, and even the most extreme of the ones that have been that have basically been suggested in support of Planet-9. Their extreme orbits, they're very essentially very elongated orbits, can be explained by known physical effects. That's what they say. So maybe
the likelihood of a Planet-9 is much reduced, but not an absolute write-off yet. But it sounds like what they're saying is that the multitude of objects out there is probably more likely to be the influence than one massive object.
Yes, that's right. Exactly. So, and the fact that we're only seeing a small number of these objects, and it just happens that the ones we've seen all line up in a way that's probably more to do with where we've seen them in their orbits than a real effect. So it's not as I said, it's not a death sentence, but it is really. It calms things down. It suggests that maybe the Planet-9 theory was a little bit premature. Actually, this article ends, I think, in a very, very nice way. Samantha Lawler obviously has a way with words. She says at the end, many beautiful and surprising objects remain to be discovered in the mysterious outer solar system, but I don't believe that Planet-9 is one of them. So there you are.
That's a soft landing on a very disappointing revelation.
Yeah, but don't give up on it. I'm sure there'll be people still looking for it because that's kind of what happens. That's how Neptune was found. The evidence for Neptune was, I think, a lot more convincing than the evidence for Planet-9. And sure enough, it turned up pretty well exactly where they predicted it back in the 1840s. But we're dealing with something quite different here, I think. And it's a statistical. With Neptune, what led to the discovery was hard calculations on orbital dynamics of actually the planets, Uranus and the inner planets, that you can work out from the orbits of Uranus in particular that there's something else out there. With this, what we're talking about is statistics over a large number of objects that point to the existence of Planet-9. And the bottom line might be that we just haven't been looking at a large enough number of objects, that we've been selective about what we've seen. So, yes, there you go. I was going to say,
truth be told, we can live without it.
we can live without it. I think people, if they do have a copy of Exploding Stars and Invisible Planets, should still read the chapter anyway, because I talk about other things that have been discovered by the same sort of technique. It's not just about Planet-9.
Yeah, they could keep reading the chapter unless, of course, they can't buy any toilet paper. And, of course, there you go.
That's the
problem solved.
That's right.
All right. Well, we will certainly keep an eye on this story because you just never know with astronomy. Some other curveball could pop up that goes, the only reason that exists is because there's a Planet-9.
Yeah.
We'll have to wait and see. But it now looks like perhaps not. You're listening to Space Nuts with Andrew Dunkley and Fred Watson.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Once again, a special thanks to our patrons, the people who put a little bit of money every month into the Space Nuts podcast. And there are a couple of options these days. If you have one preference over another, you can do it through Space Nuts Supercast website, which is spacenuts.supercast.tech. And there are different options there. You can buy bundles for $5, $6, $7 a month or thereabouts, or you can go to Patreon. We have a big following through Patreon, and mainly because we've been doing it through Patreon longer. But you're more than welcome to sign up through either of those platforms, Supercast or patreon.com/spacenuts. Now, as I've said many times, it is not mandatory. But if you feel compelled to put a few dollars in our kitty so that we can do extra things like purchase new recording equipment, that kind of jazz, you're more than welcome to do so through either of those platforms, Patreon or Supercast. Now, Fred, let's move on to the next topic. And that is an interesting discovery about a galactic crash, I think they're describing it, this dwarf galaxy that keeps smashing into the Milky Way. And they now believe, perhaps, that it's why we exist, why our solar system is here, which does make for a compelling story, I imagine.
Indeed, it does. It's a great story, and it's actually very close to home, is this, Andrew, because the dwarf galaxy that we're talking about that smashed through the plane of the Milky Way was discovered at the United Kingdom Schmidt telescope. And I think it was discovered when I was astronomer in charge there. Actually, it wasn't. It was just before. It was earlier on than that. So it was a discovery made. The research paper discovering it actually was published in 1994. I think I'm right in saying that.
That's the year I moved here. I've been here for 26 years now.
Yeah. Anyway, but it was discovered at the UK Schmidt telescope. Actually, it might have been 1995, which is the year I took over as astronomer in charge. But I worked there before I was astronomer in charge. I worked there for 10 years as just one of the oiks taking photographic plates, and that was how this dwarf galaxy was discovered. So there you are. So maybe a dwarf galaxy that was discovered by the United Kingdom Schmidt telescope is the reason why we exist, which is a nice. We should make something of that.
You should put a,
not quite sure what.
A trophy.
Trophy
up on the mantelpiece.
Trophy, yeah. So, all right. What's the story? And really, what allows us now to make the absolutely exquisite observations that this story requires? The facility is the Gaia spacecraft. That's the new part of this story. Gaia is a European mission, was launched probably 5, 6, 7 years ago, maybe. It's essentially doing absolutely high precision measurements of the positions of stars in our galaxy, the Milky Way galaxy. And its total, I think so far, is about 1.5 billion that they've measured. It's a huge number, many, many more than we ever did with the telescopes like the Schmidt back in the 1980s. But they also measure their velocity. So what the Gaia data have shown us is the way these stars are moving. And so the Sagittarius Dwarf Galaxy, and as you can guess, it's principally in the constellation of Sagittarius. We've known for a long time that that this is one of the dwarf galaxies that is in orbit around our own Milky Way. And more than that, it's actually being dismantled by the Milky Way. The two best examples are the Large and Small Magellanic Clouds. They're much, much bigger than the Sagittarius dwarf, but they are too being torn apart over timescales of millions of years, hundreds of millions of years probably, and eventually will wind up as part of the halo of our galaxies, that halo of stars that surrounds our galaxy. So the Sagittarius dwarf is in the same boat. It's being torn apart by tidal forces, but it's much smaller, and it's actually nearer to the plane of our galaxy than the Magellanic Clouds. And what's now happened is that because of the observations of the Gaia program, the Gaia spacecraft being able to measure these star positions very accurately, what it means is that you've only got to wait 2 or 3 years. Actually, it's probably about 5 years, but you measure them again and they've moved, and so you can actually work out how fast these stars are traveling. And so they've done that for the Sagittarius dwarf, and that then allows you to track back as to where it's come from and how it has behaved in its interaction with the Milky Way galaxy. And so the models that allow you to do this show that the Sagittarius dwarf galaxy has basically fallen through the plane of the Milky Way 3 times.
Oh, wow.
First one was about 5 billion years ago, then again about 2 billion years ago, and the third time only 1 billion years ago. And what they're saying, and I should say this is research that's done actually by astronomers at a place I used to have a lot to do with, Instituto de Astrofísica de Canarias, which is the Canary Islands Astrophysical Institute. Pardon my Spanish. It's in Tenerife. They operate telescopes in La Palma, and I used to work there quite a lot because there's a British facility there as well, or it was. It's now much more collaborative than that. So the people at IAC, it's called Instituto Astrofísica de Canarias. That's the place where this work has been done. So what they looked into was, first of all, the model. And the model shows that the Sagittarius dwarf has whacked through the Milky Way 3 times. But you can come at this from a different angle. You can look at the star formation history in our galaxy, and you can do that by looking at star colors, luminosities, distances. You can basically do this giant analysis because there's such a huge amount of data coming from Gaia. And it turns out that our Milky Way has 3 periods of increased star formation, which peaked 5.7 billion years ago, 1.9 billion years ago, and 1 billion years ago. And they're exactly the times that the Sagittarius dwarf is believed to have kind of punched its way through the disk of the Milky Way. So what's happening here is that gravitational interactions, as this dwarf galaxy with all its stars passes through the Milky Way, they trigger the formation of new stars, because there's the plane of the Milky Way is rich in hydrogen, and that's the raw material of stars. So this disturbance is what, there's a kind of compression of gas, and that actually kicks off the star formation. And so what they are suggesting is that period of enhanced star formation 5.7 billion years ago is probably the same, what you might call the same batch of star formation, the same period of star formation in which our sun formed. The sun formed about 4.6 billion years ago. So it's a little bit more recent than that, but the sun could be, part of the end wave of this star formation that was caused by that first transit of the dwarf galaxy through the disk of the Milky Way. It's a very nice story, I have to say. It brings together the the many facilities that we've got to do astronomical research these days, but in particular the Gaia project, which is really an excellent project and is doing remarkable work.
A client met his banker to discuss opening a restaurant in a busy airport. In us, he found a partner that understood the importance of reaching for the sky. First Horizon Bank. Let's find a way. Go to firsthorizon.com/Mac.
Fargo, the new virtual assistant from Wells Fargo, makes banking faster and easier. Like this.
Fargo, what's my checking account routing number?
And this.
Fargo, turn off my debit card.
And this.
Fargo, what did I spend on groceries last month?
And that's just the beginning. Do you, Fargo? You can in the Wells Fargo mobile app. Learn more at wellsfargo.com/getfargo.
Terms and conditions apply. Your mobile carrier's availability and message and data rates may apply. Wells Fargo Bank, N.A., member FDIC.
Yeah, and these galactic collisions are not unusual, really, are they? I mean, we've talked before about our impending collision with Andromeda in 60 gazillion years' time, but these things are happening all the time. There's a couple of others that are happening as we speak, are there not?
Yeah, there are. We see them, the most famous of the antenna galaxies, two galaxies that are very close together, and their spiral arms are kind of being spread out, and it looks just like an ant with two giant antennae sticking out of its head, which is why they call the antenna galaxies. And that's the disturbance that's sort of stripping off the spiral arms of the galaxies. And now that sort of thing happens when you've got two galaxies of a similar size colliding, and it's what will happen. And it's about 3.5, I think, billion years. Should be in your diary, Andrew. We've talked about it enough.
I know. I just, I never look at my diary.
3.5 billion years down the track, this is going to happen to ours. That's probably what the end product will be. It'll take a few billion years to settle down, but we might wind up looking a lot like the antenna galaxies. I've seen simulations of what this will be like. But with a dwarf galaxy colliding into a big galaxy like ours, the outcome is different, because the big galaxy has enough mass that its shape is not dramatically affected. Although these authors are suggesting that those collisions with the Sagittarius dwarf through the plane of our galaxy might well have given rise to the spiral structure that we see in our own galaxy now, that maybe it had a different spiral structure before that. And what we're seeing as in terms of our spiral structure, and we can map it using infrared and radio telescopes, that might be a result of these collisions, which is itself an interesting idea.
Yeah, and the bottom line being that mathematically the timing is exactly right for the birth of our sun, therefore our solar system.
Yep, so we might not have been here without all this, which is a very sobering thought.
It is, rather, but if it didn't happen, we wouldn't know about it, would we?
If we weren't here, we wouldn't know about it either.
Exactly. All right, fascinating. You're listening to the Space Nuts podcast. It's episode 205. Andrew Dunkley here with Fred Watson.
0G, and I feel fine.
Space Nuts.
Just a reminder too, if you would like to visit our website, you can check out the Space Nuts shop. It's Bytes, bitesz.com/space nuts. You can listen to back episodes of the podcast there, or through your favourite podcast distributor like Google, Apple, Spotify, Android, iHeartRadio, Stitcher, Podbean, Pocket Cast, Castbox, or you can set it up as an RSS podcast feed. All sorts of options. But while you're there, check out the shop, because all sorts of amazing things are available for sale, and a few not so amazing things like some weird sci-fi novel. But T-shirts and cups and polo shirts and you name it, all available through the Space Nuts shop on our website. And a few of Fred's books there too, even though one's got a redundant chapter. But we won't be talking about that today, will we, Fred? Now let's get to some questions. This one comes from Peter in Burwood in Victoria. Hi, Andrew and Fred. Thank you so much for a wonderful podcast. Oh, have we done one of those? Anyway, my question is, recently I was thinking about Elon Musk's Starlink satellite system, which made me wonder if there is some type of global authority who determine where you can or can't place a satellite in orbit. With the ever-increasing number of satellite launches combined with projects like the Starlink system, I imagine there should be an authority who controls the occupation of satellite orbits. Either way, I think your answer will be very interesting. Keep up the great work, boys. Thanks, Peter. Thank you, Peter. Yeah, it is something to wonder about. We've had a lot of people talking about the observation of launches and the lining up of the satellites and lights in the sky. I mean, we're talking thousands of satellites, really, that are starting to pop up there. And one wonders, is there a global authority that oversees all this?
The answer is really interesting, exactly as Peter says. Either way, I think your answer will be very interesting. So you've got to deal with different sorts of satellites. The geostationary satellites, these are the ones that basically we mostly use for telecommunications. They're the large satellites. They weigh 13 to 15 tons. They're huge things. They're sitting up at a distance of 36,000 kilometers above the surface of the Earth, because at that distance, they go around once per day. They follow the rotation of the Earth. So they're always over the same point on the Earth's surface, and they beam stuff down to users on the planet. So that region of space is very, very specific. They've got to be at exactly the right distance. It works best if they're right on the equator. And so you can imagine that there you've got a very, very narrow region within which spacecraft can actually successfully operate. And that region is allocated. I meant to follow up. I think it's probably the communications authority that does that, the International Telecommunications Body. So you're allocated your orbital slot. And I know because we have a good friend who actually operates these satellites. She works for Optus. And I know from talking to her that much of their work is to keep the spacecraft on station, because gravitational forces from the moon, from the sun and the planets actually tends to disturb the position of the satellites. And so they've got to do periodic burns of their thrusters just to keep them in the right place so that they fulfill the rules. They're actually in a box. There's a kind of box of space that they're allocated, and they've got to keep them inside that. So that's the sort of thing that you would expect to find in the space world. But from my reading of the situation, I knew there was a but. There's a but, yeah.
There had to be.
From my reading of the situation, in low Earth orbit, it is much less controlled. And actually, I love there's a Washington Post article. It's a few years old now, written by Christian Davenport. And he titled his article, "Companies Flood Earth's Orbit with Satellites, but No One's Directing Traffic." And
wow.
That's kind of it. And, that's how we've suddenly got this flood of satellites that have certainly taken the astronomical world by surprise. The Starlink satellites and the OneWeb ones, which were also being launched. OneWeb, I think, is now in financial difficulties, and I'm not sure what the future of that is. But SpaceX is going gangbusters with their plan to launch 12,000 Starlink communication satellites. So the reading of the situation I have, and once again, this is a few years old. I'm going to read from an article by Jeff Faust in the Space Review, and he's talking about the authorities. He's basically this is basically an article that's advocating somebody directing the traffic, basically. But there's a paragraph here that I think tells the story as it is. I believe this is still the case today. It may have changed, but I think it might still be the case. Today, the concept of on-orbit authority, and that means an authority that looks after spacecraft on orbit. Today, the concept of on-orbit authority is a grey one for commercial spacecraft. In the United States, the FAA, that's the Federal Aviation Administration, is that right? The FAA's Office of Commercial Space Transportation, AST, regulates the launch and re-entry of commercial vehicles. However, it has no direct ability to regulate spacecraft between the end of launch and the beginning of re-entry, including oversight of their activities or ensuring that they're in the proper orbits and don't pose a risk to other spacecraft. It's a bit worrying, isn't it?
It is fascinating. Yeah, so I mean, within our atmosphere, we have air traffic control, which regulates the flight paths and the slots and the altitudes of aircraft.
Yes,
but it sounds like in space, it's a different kettle of fish.
Yeah, so this article is quite complex. That the stuff we're talking about. Let me just read a bit more. FAA officials have made it clear in recent years that they would like to close that regulatory gap between launch and re-entry, seeking on-orbit authority for commercial vehicles. The FAA believes it's time to consider closing the current regulatory and safety gap between launch and re-entry, said George Field, FAA Associate Administrator for Commercial Space Transportation, at the opening of the FAA's Commercial Space Transportation Advisory Committee meeting in Washington, May the 8th. That was actually 6 years ago, so it's quite a while back.
And nothing seems to have changed much.
I don't think so. He says our goal will be to promote orbital space transportation safety, including for orbital debris mitigation for spacecraft whose primary function is transportation. So one thing to say is, of course, these things are all tracked. There are authorities, principally, with the defense agencies, but there are authorities that track everything down to about 100 millimeters in size by radar. So we do know where things are, but that doesn't mean, or at least where the big stuff is, because there's millions of bits that aren't tracked smaller than that. And that's the danger of space debris. But with the big stuff, at least we know where they are. But there's nothing that says, well, it should be here and it's not here, so we're going to find them or something like that. All that's telling you is where the space entities, the spacecraft and the bits of debris, whereabouts they are in their orbits. So very interesting stuff. I'd like to...
Indeed. It sounds like we're kind of in the cowboy era of space at the moment when there was no law. There was just, you and your six gun.
Yes.
Until barbed wire came along, that ended the era of the cowboy.
Yes, that's right.
So maybe we could send up some barbed wire.
Yeah.
It's probably already up there.
Yes, barbed wire equals space junk, I'm afraid. That's the trouble. But yeah, I'm to be honest, I'm a bit surprised at this. I thought things had moved on. But so far, and I confess I haven't done an in-depth search. And what I should do, I do know people who are deeply involved with this kind of thing. And I will talk to them because I'd like to know, I'd like to know the answer to this myself as to whether there is a movement in place. I mean, we've still got COSPAR. There's a meeting of COSPAR, the Committee for Space Research, that's been going since the 1960s. It's the kind of global authority for space work. They meet every 2 years. They were supposed to meet here in Australia this year, actually in August, but that, of course, has been postponed due to COVID-19. And I think the plan at the moment is meeting at the beginning of next year. But that's the sort of body that you would expect will be looking after this kind of thing. Interesting stuff. Indeed. And, of course, very interesting. What's brought it home is the fact that, yes, we've got Elon putting his spacecraft up there. Elon is not a cowboy. He's an extremely able entrepreneur. And we've only, we started this segment off lauding his praises for getting Doug and Bob up there into orbit for the first time. And it's marvelous.
In fact, it is marvellous what he does, and he's becoming quite a hero amongst those of the astronomical fraternity. And I've actually read some of the material that's been online, particularly on social media, in response to what he's done. And people adore him. I know he's got his critics, but people adore him for being in a position to do this and doing such amazing things. He's being looked at as quite a folk hero.
Yes, that's
rightly
right.
so, I suppose.
Yeah, but there's he's not the astronomer's favourite because of the SpaceX constellations.
I was going to get to that. Yes.
Yeah, and there's ethical issues as well with his plans for Mars, which I was in a meeting a couple of weeks ago. We were talking about this, the ethics of spaceflight, and it's not clear that he's got a mandate to go and colonize Mars, which is certainly on his agenda. So, very interesting stuff. And maybe that's the way it is. You've got pluses and minuses with everything we're trying to do at the moment.
So he's not the Messiah. He's a very naughty boy. No, I'm only kidding.
Well,
I couldn't help myself.
No,
I not.
Yes, I like that.
Okay, thank you so much for the question, Peter. I really appreciate it, and certainly opened up an interesting discussion. Now let's move on to our next question. This one comes from Daryl, and it's an audio question.
G'day, Space Nuts. Daryl here. I was having a chat with a mate the other day and was discussing the centre of the universe. He seemed to feel that there wasn't really a centre of the universe, and I think that there is. Can you tell me if there is a centre of the universe, and what would you find there? And the other question I have is the deep field photo that was taken a few years ago by Hubble, is that towards the centre of the universe, or is that on the outer edge of the universe? Anyway, love the show, and thanks very much.
Thank you, Daryl. I strongly suspect Daryl is Australian, Fred.
Maybe. Anyway, it's great to hear from him. Thank you, Daryl, for your question. It is one we've been asked before, but it is a really interesting one, and it's kind of counterintuitive. And the glib answer, and it is glib, but it's actually factually the answer, is that there really isn't a centre to the universe that we can perceive. So let me start. Actually, I think probably the way to do it is to start with the second question that Daryl has about the Hubble Deep Field and the ultra deep fields. These are photos that show the universe back as it was almost 13 billion years ago. They're going back a long, long way. That image, you could take it in any direction and you'd get the same sort of thing. You wouldn't get the same galaxies, of course, but you get the same distribution. And that is because, to the best of our ability, to determine it, the universe is the same in all directions. It's isotropic, is the technical term. And that kind of takes us back to the first question: does the universe have a center? Well, if it does, we can't perceive it. But the glib answer that I was referring to a minute ago is that because the universe is believed to have emerged from what's called a singularity, a point with no dimensions, then everywhere was at the center. Essentially, there was no specific center to it, because the whole thing expanded from a single point. Now, that's really hard to get your head around.
Yes,
we always think of an explosion, something expanding. We always think of looking at it from the outside, but it's the geometry that we intuitively think of when we think of something expanding doesn't really work with the universe. The observation we can make is that it is expanding. It seems to be expanding in the same rate in all directions. There have been issues with that. We've discussed those within the last few weeks about some people think that the acceleration is not the same in all directions, but I think the general consensus still think it is. So that's the observation that we make, that it's expanding. And then from that, you work backwards to get the idea that there was a single point, a singularity from which it expanded. But that tells us nothing about any center or any, preferred direction in the universe. To all intents and purposes, it's the same everywhere. So no center, and really no chance of finding one. Although I have to say that as time goes on, we get more and more detailed mappings of the expansion of the universe. And it is just possible that one day somebody might find something that says, well, there's a bit more of the universe on this side than there is on that side. And that might, impose an idea of direction on it. But it's, to be honest, it's hard to see even that happening, because we are limited currently in how far we can look by the cosmic microwave background radiation, which is a horizon that we can't see any further than. We're looking back to the flash of the Big Bang. And within that sphere of visibility, the universe is highly isotropic, very much the same everywhere. And it's only the tiniest ripples on that cosmic microwave background radiation that tell us that the Big Bang itself had echoes in it that eventually led to the formation of galaxies. They're the frozen signals of acoustic waves within the Big Bang itself. So apart from those tiny variations, the Big Bang is the same everywhere. And that suggests that, yes, there was no center to it, that what we see is this, a universe that's isotropic everywhere. And no matter how hard we looked, we wouldn't see any evidence of something different. It's
hard to get your head around, because I know where Daryl's coming from, because you think of the Big Bang as happening somewhere, and everything bursts out from that point in the same direction, or in all directions at the same speed, and ever expanding. So surely if you go back from the outside in from all directions, you've got to come to a point in the center. I guess that's what he's getting at.
Yeah, but the thing is, there was a place where the Big Bang was, and it was here. And that's because, it's here everywhere, because it did come from a single point. The thing that makes it difficult is that on very large scales, geometry doesn't work the way we think it does here on Earth, because it's affected by gravitation. And, the idea that we had back in the 70s was that the universe might be closed, what we call a closed universe, which means that if you head off in a straight line, eventually you'll come back to where you started from. That it's because the universe has a geometry that brings you back to where you started.
Right.
That's actually not the current view of the universe, but what the lesson it gives you is that you can't just rely on our intuition when it comes to what shapes things are and how things work. And that's why, whilst we might be wedded to the idea of a center, the evidence is that there isn't one, because geometry doesn't let you have one. So it all sounds like waffling, I know, but believe me, that's what the mathematics tell you and what the gravitational theories tell you.
Well, I'll give you a mathematical probability. Your explanation is going to spawn at least one or two more questions about this.
Well, that's good if it does, because the questions are always great. We learn from the questions. So thank you for everybody who sends them in. Because
yes, indeed, and thank you, Daryl. That was thought-provoking, and the answer to your question is yes and no, or no, or could be no and yes. Jury's out on that one. But if you do want to create an audio question for us, you can do that at our website as well, bytes.com/spacenuts. Just make sure you've got a microphone of reasonable quality, and an internal microphone on a laptop will do the trick. And you just press start recording, tell us who you are, where you are, all your bank account details, how much you've got, No, you don't need that last bit. We just don't want to know who you are or where you're from. But yes, name and where you're from, and ask your question, and we'll slot it into the Space Nuts podcast if we have room, and if we haven't answered it before. Although we've had that one before, but it's always worth talking about. And there always seems to be something new to discover with repeat questions. So don't feel too worried about that. Send your questions to us on email as well. We take them in written form too, so easy to deal with either way. So thanks, Daryl. Thanks to everyone who's contributed this week. Thank you, Fred. We've got to wrap it all up for another week.
Yeah, yeah, we should do, shouldn't we? That's been a bumper edition today.
Sure has.
Due to your guest and he's rambling on about everything. So I'll try and be more concise next time.
I don't think people would like it if you were more concise, Fred.
No problem. Anyway, good to talk, and we'll speak again soon, Andrew.
Indeed we will. Thank you, Fred. Professor Fred Watson, Astronomer-at-Large. And from me, Andrew Dunkley, thanks again for listening. We'll catch you next week on another episode of the Space Nuts Podcast.
Space Nuts. You've been listening to the Space Nuts Podcast.
Complete Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.
And a few galahs by the sound of it.
Yeah, that's right. Actually, they're
all right now.
Yeah, they're cockatoos.
Oh, are they?
Okay.
Yeah, we get cockatoos, corellas, pink and grey galahs.
Yeah. Do you get king parrots? We used to get king parrots in.
We do sometimes if the seasons are right.
Yeah.
We have at the moment because they've been driven in by the drought, but normally not. No, but we've had some unusual breeds turning up here because there's nothing for them to eat or drink out in the bush. But that's changed, so I suspect some of them will move on. But we've got some at the moment that are out there. They're beautiful birds.